Lesson 3.8, frequency tables. Our objective for this lesson is to be able to make a frequency table for a data set. Let's start by defining two different types of data, qualitative data and quantitative data. Qualitative data consists of values that can be placed into non-numerical categories. So an example might be eye color. We'd have different categories for brown, blue, green, hazel, etc. But those aren't numbers. They don't represent measurements. Instead, they represent qualities. Another example of qualitative data might be letter grades. So A, B, C, D, and F would be qualitative data. On the other hand, you have quantitative data, which represent counts or measurements. So let's say instead of saying that you have a B in the class, maybe you say I have an 87% in the class. So that's an actual measurement. It represents the percentage of the total points that you've earned in the class. So qualitatively, you have a B. Quantitatively, you have an 87%. So qualitative data is non-numerical. Quantitative would be numerical. Next, a frequency table. So a frequency table is a table showing the number of times or frequency that each category represented in the table appears. So let's say I wanted to create a table of all of my students and what grade they've earned in the class. I might have categories for A, B, C, D, and F, and then next to each of those categories, I'd put the frequency, the number of students who have earned that grade. So maybe I have 30 A's and 50 B's and 40 C's. That would represent a frequency table. Now on our frequency table, we're going to have two additional columns. One is for relative frequency. So relative frequency for a category expresses its frequency as a fraction or percentage of the total. So this is often going to be more helpful. So for example, if I say I have 30, that 30 of my students have earned A's in the class, that might not be meaningful to you if you don't know how many students I have. But if I have 150 students, then the relative frequency would be 30 divided by 150, which is 0.2 or 20%. So that's going to be more meaningful if I say 20% of my students have an A, as opposed to just saying 30 of my students have an A. So that's relative frequency. And then we have cumulative frequency. So cumulative frequency is the number of responses in a particular category and all preceding categories. So for example, if 30 of my students have an A and 50 have a B and 40 have a C, then we can add up all of those as we go. So to the 30, we'd add 50, and so that means that 80 of my students have at least a B in the class. And then we'd add the 40 and say that 120 of my students have at least a C in the class. So cumulative frequency is the number of responses in the category that we're looking at and all the categories that have come before. Our example asks us to create a frequency table for this set of data, which we're told represents the ages of 20 randomly selected college freshmen. So when we create a frequency table, the first column is going to be the category that we're looking at, in this case, age. Then the second column is going to be the frequency. The third will be the relative frequency, and the last column is going to be the cumulative frequency. So let's start by filling in all the different ages that are represented in this data set. So we can see that the youngest age is 17 and the oldest age is 24. So let's go ahead and just enter all the ages from 17 to 24. So we've got 17, 18, 19, 20, 21, 22, 23, and 24. Now we need to count up how often or how many 17-year-olds there are, how many 18-year-olds, etc. So there are 2 17-year-olds. 18-year-olds, we've got 1, 2, 3, 4, 5, 6, 7, 8 18-year-olds. 19-year-olds, we've got 1, 2, 3, 4. 20-year-olds, we've got 1, 2, 3. Then it looks like we've got 1 21-year-old, 1 22-year-old, no 23-year-olds, and 1 24-year-old. All right, so that's our frequency. All that's involved there is just counting up the number of times that category occurs. So next is our relative frequency. And so what we're going to do there is compare this frequency to the total number of data points, which here is 20. So we're just going to divide this 2 by 20 and then put this relative frequency in a percentage. So 2 divided by 20 is 0.1 or 10%. So our relative frequency here is going to be 10%. 8 divided by 20 is 0.4 or 40%. 4 divided by 20 is 0.2 or 20%. 3 divided by 20 is 0.15 or 15%. 1 divided by 20 is 0.05 or 5%. And that's going to be the same here. 0 divided by 20, of course, is 0%. And then another 5% here. And we can check to make sure that all of these add up to 100%. So 10 plus 40 is 50, plus 20 is 70, plus 15 is 85, then this would be 90, 95, 100%. All right, now our cumulative frequency. So we're going to start by just the cumulative frequency for this first row is going to be the same as the frequency for this first number here. So this is going to be 2. And then we're going to add 8 to that 2. So our cumulative frequency now is 10. And then we're going to add 4 to that 10. So that gives us 14. Then we'll add 3 to that 14. That's 17. Then add 1. That's 18. Add another 1. That's 19. Add 0. So we're still at 19. And then finally we add the last one to get us our 20. And the reason that this cumulative frequency is helpful is if we want to know, for example, how many freshmen are 20 years old or younger, then we could just look to this 20 here and we can see that 17 are 17, 18, 19, or 20. So that's our cumulative frequency up to that point.